So let's investigate the isotopic spin, flavor, and color quanta of the decay of the T quark into the B quark. And so isotopic spin. The isotopic spin for the higher generation particles, the generation 2 and 3 quarks, should be 0. And if we look on this generic D quark, we have 3, 6. 1, 6 plus 1, 6 plus 1, 6 equals 3, 6, which is minus 1 half. And that minus 1 half, though, added to the isotopic spin on this boson, which will be 1 half, and so that will indeed give us an isotopic spin of 0 on the T quark, because the particle-antiparticle pair, of course, contributes no isotopic spin. And we will see that will just be the opposite for the anti-T quark. Now, let's look at the B quark. The B quark, we have, similarly, the generic D quark contribution is minus 1 half. But in this, and then the unflavored neutral boson provides no contribution to the isotopic spin, but the flavored neutral boson here, we have minus 1/3 and 0.83 5/6, and we'll see that this 5/6, take away the 2/6 of the minus 1/3, will give us plus 1 half, which will cancel out the minus 1 half on the generic D quark, giving us an isotopic spin on the B quark of 0, as it should be according to the standard model. Now let's look at the W particle that is emitted, and we will see that we have on this particle-antiparticle pair, we have no contribution to the isotopic spin, but we have a contribution to that isotopic spin of plus 1 half to this, in this boson plus. But then when we look at this neutral boson, we will see that we have minus 1 half, and so minus 1 half and plus 1 half will give us 0, as it should be, because we should get no contribution. Since we started with 0, we should have 0 for the isotopic spin. Let's look at flavor. And so only these prime flavored rishons contribute to the flavor charge. And so we can see initially on the T quark, we have a flavor charge for the T quark of 1, which is what is indicated for the standard model. And these two particle pairs have flavor that cancels each other out. And of course, we'll see for the anti-T quark, we will have a flavor charge of minus 1. And there's 0 flavor charge on the non-flavored, of course, V and anti-V prime rishons. Now let's look at the B. The B quark, the generic, has no flavor, and there's no flavor, but now we have a flavored neutral boson, and the flavor on that neutral boson is minus 1 for the B, as is indicated for the standard model. And the W charge, the W particle, be carrying away a flavor charge of 2. And here we'll see that these two particle-antiparticles will annihilate, and this V prime flavored Richon will combine with this non-flavored Richon to form a similar pair here to provide a flavor charge of 1 on the NTB. Whereas here, this V will annihilate with this anti-V, and the flavor charge will disappear, and this unflavored T will enter into a combination with this anti-T Richon, performing to give the other necessary neutral boson to provide for the appropriate quanta for the NTB. Now, let's look at color. So, as we can see, color charge is indicated by half of the semicircle on the right. The color charges from the bottom and the left cancel, or as you can see in the case of the V, the color charges cancel from the top and the left. And so the color charges are always indicated by the color of half of the semicircle to the right. And again, you can see the quantum number are displayed when you hover over the Richon. And so we can see here that we have complements blue and orange, which cancel, and leaving the color charge of red on this generic D quark. And here, the combination of red and yellow gives orange, and we have blue here. And so the color charge cancels for this boson plus. And similarly here, we have red, combination of purple and orange giving us red, combination of blue and yellow giving us green, and then those cancel one another out. So the starting color charge on the T quark is red. And of course, in this exchange, we exchange two Richons which have the same color charge, orange. So this Richon, this generic D quark will have the same color, red. And so here again we have orange and blue, so these cancel. And here we have red and green, so these cancel. So the color charge is red on this B quark. And then we have the W particle, and we can look and see we also have canceling pairs, orange and blue, and green and red. And we can see that since this is the NTT we started with, it will be just the opposite of the T quark. And so all the color charges are consistent. We start with a red T quark and it decays to a red B quark. And when this colorless W particle is absorbed by the NTT to become an NTB, it will remain with a green color charge, which is the opposite of the red. And so there we have all the quanta, except I will not in this video talk about Richon number, because Richon number is a number that, due to this pre-quark model, supersedes baryon number and lepton number.